Hey everyone, we're going to work through examples 3 through 5 on 3.2 day 1 notes. So the next thing that you're going to be asked to do, like in example 3, is to evaluate a logarithm. Whenever I am evaluating a logarithm, I am thinking, what exponent do I need to raise the base to in order to get my argument, which in this case is 16. Sorry, I hope that whole thing wasn't blurry for you. Okay, so I'm sorry if that was blurry, but I am always thinking, what exponent do I need to raise my base to in order to get my argument? Okay, and so I see that log base 2, if I write 16 in terms of 2, I know that 16 is 2 raised to the 4th. So log base 2 of 16 is going to be equal to 4. For letter B, I need to think, what exponent do I need to raise 7 to in order to get 1 over 49? So hopefully as you go through this and you get some fluency, you'll be able to do this in your head. But if you're not at that point yet, I am going to rewrite my log with my same base, and I want to rewrite my argument in terms of this base. Because I have a reciprocal 1 over 49, this is a clue to me that I'm going to use a negative exponent. Okay, and so I recognize that 1 over 49 is the same as 7 to the negative 2 power. So log base 7 of 7 to the negative 2, my exponent here is negative 2. Okay, my next one, again, I am asking, I have a base of 25, and I have an argument of 5. So I want to see how I can relate 25 and 5 using exponents. So I recognize that 5 is the square root of 25, and I recognize that the square root is the same as writing an exponent of 1/2. So my value here is 1/2, because 25 raised to the 1/2, or the square root of 25, will be 5. For part D, again, I am looking to write my argument in terms of my base. So I recognize that if I have a radical, I can write that as a rational exponent. So log base 2 is going to be 2 raised to the 1/5. That's equivalent to the 5th root of 2. And so the exponent that I need to raise 2 to in order to get 2 to the 1/5 is 1/5. Okay, so for letter A, my answer was 4. For letter B, my answer was negative 2. For letter C, my answer was 1/2. And for letter D, my answer was 1/5. So I would like you to pause the video at this time. If you can do these in your head, you are just looking for a number for your answer. If you're not quite there, you want to be rewriting each of your arguments as the base to an exponent and then evaluating the logarithmic expression. Okay, so hopefully you can follow my logic. For number 1, I got 2. For number 2, I got -3. For number 3, I got 1/2. And for 4, I got 1/7. So there are some basic logarithmic properties involving 1. I never really memorized these. I think if you think about the definition of a logarithm, they're pretty straightforward. But if you are a memorizer, these might be 2 that you want to memorize. The first one says that the log base b of b is 1. And think about what this means. It means b raised to the first power is b. And I think that makes sense just because we all know that anything raised to the first power is just going to be itself. Our second power is if the argument is 1, it doesn't matter what the base is as long as it's positive and not equal to 1. It's the logarithm base b of 1 is always going to be 0. This one is one that is definitely worth memorizing if you're a memorizer. But think of it. Any base b raised to the 0 power, anything raised, any positive number not equal to 1 raised to the 0 power is always going to be 1. So if you are thinking about this in terms of the definition of a logarithm, you're thinking 7 raised to what power equals 7? I think that's pretty easy to see that 7 raised to the first power is 7. And similarly, if you were going to use the property, you'd notice that you have the same base. The base and the argument are equal. So if you memorize that property, the answer should be 1. For part B, you're thinking 5 to what power is going to give me 1? And hopefully you'll realize that would be 0 because 5 to the 0 would equal 1. Again, looking at our property here, we have a base that's positive and not equal to 1. We have an argument that is equal to 1. So our property says a log of any base of 1 is equal to 0. So log base 5 of 1 is 0. Okay, so again, please pause the video and try the U-Try problems. You really want to get it so that these come this quickly, that if you see log of a base is equal to that same number, it's equal to 1, and log of a base of 1 is going to be 0. Okay, our last examples. So these are the inverse properties of logarithms. So basically, they are saying if you have log base b of b to the x, that's equal to x. I think, again, this is pretty straightforward given the definition of logarithms. You would say b to the x equals b to the x. Right? If we're reading this, b to the x equals our argument, which is b to the x. I think that one's pretty straightforward. Our other one is a little harder to understand. So I want to wait until we look at example B, and I think that one will make a little more sense. But basically it's saying if you have a base B and you raise that to an exponent equal to the log base B of x, then the answer is x. So for letter A, log base 4, what do we need to raise 4 to in order to get 4 to the 5th? I think it's pretty obvious that we would raise it to 5. So 4 to the 5th is equal to the argument 4 to the 5th. Using our property above, we can see the base is raised to the log of the same base to the 36. So our property tells us that this is just going to be equal to our argument. But I think sometimes it's helpful to see what this looks like out. So if I'm starting with 6 log base 6 of 36, I'm going to keep the base the same, 6. I need to think log base 6 of 36. That's the same as log base 6, and 36 can be rewritten as 6 squared. So now this 6 is staying the same, but now I want to evaluate log base 6 of 6 to the second. So log base 6 of 6 to the second, 6 to what power equals 6 to the second? Hopefully you can see that that would be 2. And then 6 squared is 36. Okay, so using the property, we can get there in one step. If we have to do it out, we can still get to our final answer. So please pause the video and try our 2 you try problems. Okay, so hopefully you can see using the properties, log base 7 of 7 to the 8th will be 8, and 3 raised to the log base 3 of 17 will be 17. I apologize for the blurriness of this video. I'm hoping you can still make out everything clearly. Remember to go back and review anything you have questions on. And please make sure you check Google Classroom for your homework assignment.